My guests today are Ava Tan and Gulnar Mirza, who are both juniors in ECE here at Cornell. Now, in addition to their academics, they've both had leadership roles. So Gulnar has been a peer advisor, which is a very important role here to help freshman students adjust to life here at Cornell. And then Ava has been involved in the local IEEE on the executive committee there. Now, both have done research in EC as well, so Ava in circuits and Gulnar multi-course systems programming. We'll hear more about that as well. And they've also been involved in the course, in the edX course. So they were the first to use the J tool that people are using, and they've developed a lot of the labs that are involved with the course. So first of all, I want to thank you for both dropping by the studio.
Thanks for having us.
So can we first start by talking about how you got interested in ECE? Was this something that happened in high school, or was this something that started while you were here at Cornell?
Well, when I was in high school, I particularly was fond of my physics courses that I took, and I was also a part of Science Olympiad, so I really liked building things, getting to work with other people on collaborative projects. And so I knew I wanted to do engineering, so that's kind of what I had in mind when I applied to Cornell for the engineering school. As a freshman here, I took an intro course with Professor Albanesi, and I found it very influential. I really enjoyed it, and it taught me a lot about the basics of computer engineering. And so that course really inspired me to try to branch out and learn more about the major and to take other courses that are required for affiliation.
Now, I didn't plant that answer with you, right? I mean, that's a genuine answer. You took my class and got you interested. Yeah. Now, how about you, Gulnar?
So I've always liked math and science courses in high school, and especially physics. And I mean, I kind of just randomly said, I'll try engineering at Cornell, and ended up liking ECE and just kind of stuck with that. It was about the end of my freshman year that I decided, and then I affiliated with the major. So
you came in kind of undecided about what engineering you wanted to go into?
Yeah, or if I even wanted to do engineering.
Oh, I see. So you were thinking about other things beside engineering?
Right.
So what else were you considering?
I guess just like the pre-med track, but I decided I didn't like just studying and memorizing. I kind of like, you know, building things and the more creative side of like actual engineering.
Now, EC is a pretty broad field. There's a lot that we cover in this discipline. So can you describe some of the courses across the range of ECE that you took here that seem to stand out in your minds?
I took digital logic my freshman year after taking your intro course, and I really liked that. That was kind of like the foundation. And after that, I've taken embedded systems and also stuff like signals and systems classes.
Okay. How about you?
So I really got interested in circuits after I took the Introduction to Circuits course taught by Professor Molnar here. And I think I just really liked the lab component of it. He really tried to make an effort to put a design component to some of the labs, and I found that very interesting. And so I went on to take microelectronics during my sophomore year, and that was also a really cool course for me because in that course we get to talk about, I guess, the building block of electronics, which is the transistor, and we even talk about it at like the device physics level. So I found that very interesting, and I'm taking a lot more courses that will build off, you know, having to have a solid knowledge about transistors.
So you're like interested, we talk about the stack in the course, right? And we talked about that in the on-campus course that you guys took, right? We talk about the stack of computing. So your interest seems to be kind of at the lower, at the circuits level. That seems to be the thing that most appeals to you?
Mm-hmm. Yes.
Okay. And so what do you find that's kind of fascinating about circuits? What is the thing that kind of interests you about that in microelectronics?
Yeah, so I think it's really cool how you can learn about the device physics at such a great detail in these courses, but then as soon as you learn about it, you abstract it away and it becomes something different. And I think that's just really cool how there's so many different layers to what you can learn. And I think that's what really fascinates me the most.
And you didn't mention circuits, you mentioned digital logic, computer organization, which is another course that we have here. So are you like not at the circuits level, or are you at a higher level, or kind of where do you fit in this kind of stack in terms of your interests, or do you not know yet?
I definitely like the computer engineering side of EC more at this point, but I'm still trying to figure it out, taking classes in different areas, so I can really explore what my interests are.
Okay. Now, in addition to courses, like a lot of these courses you talked about circuits and embedded systems, things like that, have a lab component. So what are some of the most interesting labs some of the most interesting things that you've built?
So I think one of the coolest projects that I've worked on at Cornell was actually with Gulnar Mirza. We took an embedded systems course together our sophomore year. And for our final project, we kind of had free reign over what we wanted to do. So we thought it'd be kind of fun to do something that was, creative and interesting. And we were using the microcontroller that we had used in the class for other labs. So we came up with the idea of an iPod Shuffle karaoke machine, kind of. And so basically what we did was...
an iPod Shuffle plus a karaoke machine?
Yeah, it was kind of...
In one?
Yeah, it was a 2-in-1, basically.
So how's that work?
Right, so the iPod Shuffle, well, we ran into a couple issues with the lab, but how we decided to implement it at the end was to hard code a couple songs that we liked. And one of them was the Cornell alma mater, but we decided to also go with Hot in Here by Nelly and
Britney Spears.
Britney Spears
again. Yeah.
Right. And so the microcontroller has a little button that you can press on it. So we thought it'd be cool if we've added sort of like a random element. So whenever you press the button, a new song would come on. And concurrently, as the song was playing, you could look on your computer screen at the monitor and like see the lyrics show up as the tunes were playing. And we thought that was just like a really fun way to, just kind of incorporate our interests as well as the fact that we had to do like this big final project for our course into one.
So what were some of the technical aspects of that project? So I kind of have an idea of what this thing did, but how did you build it in order to accomplish what you ended up with?
Ava mentioned how we hard-coded in like notes for the song. So what really that was doing is we were sending out a square wave at a certain frequency from the microcontroller. Mm-hmm. We connected that to speakers. And so like if we did it right, we had to adjust the frequencies. We looked up like the frequency of like note A and G, for the songs. And so we connected to the speakers and it sounded like really like not great, but pretty good, like just the tune of like the chorus or whatnot.
Right. And you used a microcontroller of some kind? Did you have like a little board that you used? Like what was the hardware that you used?
We used the TI MSP430.
Mm-hmm.
Okay.
We also had to do a little bit of external breadboarding. So we had like a breadboard.
And you programmed this in, what language did you use to program it?
This was all done in C.
It was done in C, yeah. Because that's what the microcontroller board uses, is C language, yeah. Neat.
Not that anyone needs the lyrics for Britney Spears, but we also had it print the lyrics as the notes were playing onto the computer.
Now you've both done research with professors here at Cornell, so can you tell me a little bit about that?
Yes. So the summer after my freshman year here at Cornell, I worked on a small project with Professor Jose Martinez. Another student and I worked to measure performance of different multi-core processors. So I worked with a Cavium network processor, which had 32 small cores, or like processing units, and my partner worked with a general purpose Intel processor, so like 2 or 4 cores at most. And what we did was we ran different sorting programs on like large amounts of random numbers. And what we would do is each core, we would give it a certain amount of numbers to sort. So we essentially split up the work. And then in the end, we kind of combined the results. But what happened is we would measure the time it took for the different amount of cores for both processors. And came up with our conclusion of what was the most efficient way of sorting all those numbers.
So you took like a standard kind of sorting algorithm and then you each parallelized it for the multi-core hardware that you had.
Right, and we did multiple sorting algorithms. So.
I see. So you looked at a number of different algorithms. Right. So what did you conclude from your comparison between the Intel and the Cavium system?
Well, Intel is like a really good general purpose processor, but what we found was that the network processor, when using all 32 cores, it could be pretty efficient. Maybe not exactly as fast as the Intel one, but it could do more than just network processing.
So there were enough threads that you could have in parallel because of the algorithm that you could exploit that parallelism, all those cores with the sorting algorithms that you looked at.
Right.
It's pretty interesting. How about you?
So I've been doing research with Professor Molnar, the same professor I took circuits with, for about a year now. And my recent project has kind of been in the area of RF communications. And so
radio frequency,
yes,
RF?
Yes, radio frequency, yes. And so I guess the main concern we're trying to tackle is that, especially recently with like the advent of the smartphone, and now everyone has one in their pocket, overuse of the wireless spectrum has led to a lot of like latency problems, bandwidth problems, dropped calls, that sort of thing, especially with all the data transmission that your smartphone is capable of. And so that's kind of the problem we're trying to tackle. And so what my project is essentially trying to do is to try to optimize performance over maybe a wider range of frequencies to maybe change the wireless standards that are currently being dictated by the FCC. And so my project is basically using an LC filter, which is an inductor and capacitor in parallel, appended to a software-defined radio receiver. And the whole purpose of that is to try to see exactly how much we can improve performance over this range of frequencies, and if we could potentially maybe even incorporate this into future use.
So you're exploring a broader range of frequencies than currently you can use in
Right.
a typical smartphone to see what kind of additional bandwidth you can get.
Exactly.
Now, you're not yet seniors, but that's coming up pretty soon. So have you thought about what you want to do after you graduate?
Well, for me, I've really been looking into graduate school because at my time here at Cornell, I've been really inspired by my experiences as both a research assistant and a teaching assistant. I found it very rewarding, and I think I could potentially see myself pursuing a career in academia. And so, I'm just looking into graduate schools, specifically for electrical engineering, and that's where I want to go with my life.
How about you?
I'm definitely more interested in working in industry, like working as an engineer for a company. However, I'm also considering doing the Master of Engineering program in electrical engineering here at Cornell, an ECE.
So getting a master's, it's like a one-year program, and then moving on to industry. So your interest is in industry?
Right.
So have you thought about what industry you're possibly interested in, or are you still kind of figuring that out?
Yeah, I'm definitely still figuring that out because there's so many different areas that like ECE is applicable to, so I just have to.
Right, that's kind of like a blessing and a curse with ECE, right? It's
Right.
very broad and gives you broad training to do a lot of different things, but
There's a lot of options.
but there's so many options to kind of choose from. You kind of have to, well, you eventually like to narrow it down to something.